duality means duality theory, actually this one. So first you see the introduction. The dual problem of the above linear programming problem is obtained by means what? Suppose one linear programming problem is given. Okay, either maximum or minimization problem is given and constraints given. Then how to write its dual? How to write its dual? So first you see the dual problem of the above linear programming problem is obtained by. So first one, number one is transposing the coefficient matrix. Okay, so what do we mean by transposing of the coefficient? Transpose of the matrix. Here we need the concept of transpose matrix. Have you got earlier transpose matrix?
Yes, sir.
Yes, sir.
So how to define?
Sir, the columns and the rows are interchanged between each other with a negative sign.
Oh, yes. So then transpose means what? Rows and columns, these are interchanges. Okay, sign will be same. Okay, no problem. Rows and columns are interchange. Suppose first row, when we write its transpose, then this row will be for in transpose will be column. Okay, then row and column are interchanged, then this is called the transpose of the matrix. So here first one is transposing the coefficient matrix. Okay, next one is interchanging the role of constant terms and coefficient of the objective function. Means what? In the given problem we shall interchange the constant term of the linear programming problem and coefficient of the objective function. We interchange this. Third one is reverting the inequalities. Reverting means what? Suppose greater than symbol is present in the given problem. Then when we write its dual, then this will be less than or equal to. If less than or equal to symbol is given, then we write it into the in the dual. This will be greater than or equal to. And next one is minimization of the objective function instead of maximization of it, and vice versa. You can write one line ahead and vice versa. Means what? If problem is minimization, okay, then when we write its dual, then this will be maximization. If maximization, then this will be minimization. So this is the rule for how to write dual of the problem. So this one and actually original problem is called the primal, means given problem is called the primal. Okay, and when we write convert it into the dual, then this is called the dual of the problem. So another one is, you see, one thing, you in the last page I have given last one. All of you find out the last one, last page. Standard form of the primal. You find out standard form of the primal. Have you got this line? Standard form of the.
Yes.
Okay. So here you see. Linear programming problem is said to be in standard primal form if all the constraints involve the sign less than or equal to if it is a problem of maximization, and all the constraints involve the sign greater than or equal to if it is a problem of minimization. Clear? Means what? First we write when one problem is given, write its dual or etc. First you check whether the given problem is standard primal form or not. Given problem is, you will remember, given problem is called the primal. Okay, and when we write its dual, then convert its dual, then we convert. But before converting, first we check whether this is standard form or not. What is the standard form? Standard form is what? If problem is of maximization, then constraint all sign should be less than or equal to, or constraint sign greater than or equal to if it is problem of minimization. Means minimization problem is given, then all constant sign should be greater than or equal to. So this is the standard form of the primal. So sometime ask question, too much question, write the standard form of the primal. So this is clear or not? Everyone, anybody you have any doubt? Ovilasha?
No, sir.
So this one clear? Arif? Binoy?
No, sir. It's clear.
Okay. So first you see the, next you move to the first page of today's PDF file. You go to the first page. So you see the question. Write the dual of the problem. Write the dual of the problem. Mean z, mean means minimization z, mean z equal to 3x1 plus x2 such that twice x1 plus 3x2 greater than or equal to 2, x1 plus x2 greater than or equal to 1, and x1 comma x2 greater than or equal to 0. So first you check whether the given problem is standard primal form or not. Okay, standard primal form means what? This is given problem is called the primal problem. Okay, so here minimization problem is given, so all constraint sign should be greater than or equal to. So here you check whether this is greater than or not. Okay, if not greater than or equal to, then you make it into the greater by multiplying both side by -1. Okay, so here all are greater than or equal to symbols, so no problem, this is in the standard primal form. So first you see in solution, first problem solution, mean z equal to, so in objective function is 3x1 plus x2, so we can write in vector format. Okay, so 3 comma 1 into x1 comma x2 means what? 3 into x1 plus 1 into x2 mean x2, you see this one. So we can give the name c into x without giving the name. Okay, no problem. So this is c into x. Okay, such that next what we do, this constraint we shall write in the matrix form. This constraint we shall write in matrix form. Clear?
Yes, sir.
Okay. So matrix form means what? You see, matrix format is all the coefficient first you write. So in row wise 2, 3 and column wise 1, 1. Okay. Then x1, x2 greater than symbol. Then constant part is 2, 1. Okay. Constant part is 2, 1. Then we can give the name this this coefficient of this one, x1 and x2 we can write capital A, and x1 and x2 we can write capital X. Then greater than or equal to b, constant part we can give the b. Okay, first problem you see. Next what we do, we write its dual. So what will be the format for writing the dual? First what happen, your problem is, given problem is minimization, Then you write in the dual maximization. So we write max z. So for just for understanding, I have written suffix d, max z d for dual. You can write directly max z d just for understanding. Someone can write max z. Okay, equal to, I have given b dash and w is the in the or given problem x1 and x2 are the variable. When we write in the dual variable just change, we write w1 and w2, or you can write any variable name, means x1 x2 just we write another variable. So how we write this one, means you see, number 2 point, convert, how to convert dual, means interchange the role of the constant term and coefficient of the objective function. Okay, so in coefficient of objective function given problem is 3 1, and constant part of this problem is 2 1. So 3 1 and 2 1 interchange, here 2 1 will come in the objective function. So we can write 2 comma 1 into w1 comma w2 in place of x1 and x2. In dual problem just w1 and w2, anyone give any variable name. So this is twice w1 plus w2, such that then just I have given a dash w less than or equal to c dash. So without a dash w less than or equal to c dash, you can write directly this matrix. Means what? Given matrix form is what? First row is 2 3, second row is 1 1. So in our how to convert primal to dual, first point, transposing the coefficient matrix, means your given matrix, means given matrix format will be what? 2 3 in row. So 2 3 will be transpose, then its transpose will be 2 3 in column, 1 1 in second row. So 1 1 will be the second column. So just interchange. Then w1 comma w2 less than or equal to symbol. Then here we shall interchange already na, 2 1 in place of 2 1 will be then coefficient of the objective function, and original problem 3 1 is the coefficient of objective function will be here in the constant part, means 3 1. Okay, then just you multiply twice w1 plus w2, matrix multiplication less than or equal to 3, 3 w1 plus w2 less than or equal to 1. So this is the problem how to write the dual from the primal problem.
Sir,
So
sir, where did
yes,
A transpose W less than equals to C transpose come from? Like how, did we know that we have to like use this one?
So you see, I have written a dash w less than or equal to c dash. Okay, so a dash means what? In the dual, what does it mean? What do you mean by a dash? A dash means the transpose of a. A dash is the transpose of a, and w is the variable. Okay, and primal problem, if greater than or equal to symbol is present, then you see 3 reverting the inequality. So our original problem, means given problem, inequality symbol is greater than or equal to. So in our dual, this should be just reverting less than or equal to. Okay, and c dash here just interchange this one, means point number 2, you see carefully, interchanging the role of constant terms and coefficient of the objective function, means in the given problem, coefficient of the objective function will be in, when we convert it into the dual, then this will be your in dual constant part, and your constant part of the original problem will be you will write in the objective function coefficient in the dual. So you see this is clear or not?
Yes, sir, it does.
Clear everyone? Vishwajit? বিশ্বজিৎ প্রেজেন্ট or no? দীপাংশু বুঝে পাইছা নে?
Sir,
ঈশিতা?
Yes, sir.
Okay. So again you see the theory portion into duality introduction means what? Here today I discussed this one means how to write from one given problem. Given problem is always called primal, and how to primal problem to we write it into the dual. So you see the theory of the first page. The dual problem of the above linear programming problem is obtained by first point is transposing the coefficient matrix. Okay, so you see given problem here all the coefficient we shall write in the matrix format of the constraint. You see the problem 2 3. First row is 2 3 1 1. So transposing the coefficient matrix, when we write it into the dual, 2 3 will be the first column and second row 1 1 column will be the second row. Okay, then variable will be automatically change, x1 and x2 will be w1 and w2. Okay, next point number 3, reverting the inequalities. So in the given problem, this is greater than or equal to symbol. So in dual, when we write, then less than or equal to symbol. Okay. Then number 2 point, interchanging the role of constant terms and the coefficient of objective function. So interchanging the role of constant terms and coefficient of the objective function means what? In the given problem, 3 1 is the coefficient of the objective function and 2 1 is the constant term of the constraint. So these 3 and 1 3 1 and 2 1 interchange in the dual. So in the dual, 2 1 will be the coefficient of the objective function and 3 1 will be the constant term of this constraint. So 3 1. Okay, and next number 4 point is minimization and the objective function instead of maximization of it, and vice versa you can write. Means what? If given problem is minimization, then your when we write its dual, then dual should be maximization automatically. So this is the these 4 points are important one. Clear? Nihal, Ripon?
Yes, sir.
clear.
So first you see the theory, because what without solving problem sometime what happen, theory will not clear. Okay, so you just you find out the theory and also you see the means what see the problem, then compare with these two, then this will be clear. And another one is in the last page I have given standard form of the primal. So this is also the important question also. Means what is the standard form of the primal? So remember, if minimization problem is given, all constant sign should be greater than or equal to. And maximization problem is given, then all constraint sign should be less than or equal to. Okay. So next one will be next problem. You see, write the next page, page number 2. You see, today's write the dual of the problem mean z equal to 3x1 plus x2 such that 2x1 plus 3x2 greater than or equal to 2, x1 plus x2 greater than or equal to 1, and x1 comma x2 greater than or equal to 0. So for Starbucks, what we check first? Anybody, Roshni?
If it is in standard form or not.
Yes, the given problem is called the primal problem. So first you check whether the primal problem is standard form or not. Okay, so how to check standard form? What is the rule?
Sir, if all the inequalities are greater than or
Hmm.
equal to, if it is minimization, then all the inequalities
Yes.
should be greater than or equal to, and if the problem is maximization, then all the inequalities should be less than or equal to.
Yes, good. So this one, everyone, you see this one here. First, you check our objective function is what. Okay, so you see in your exam sometime given mean z suffix p, so you will not confuse. P means primal. Okay, zd means dual. Okay, so sometime given zp, so zp denotes the primal and zd denotes the dual. Okay, so first you see our objective function is what. So our objective function is minimization. So next immediately you check our constraint sign is greater than or equal to in our inequality constant sign should be greater than or equal to. Okay, so here, okay, because minimization and all constants are greater than or equal to. Then solution, you see, I've written the given linear programming problem is in the standard primal form. So mean z equal to 3x1 plus x2 such that twice x1 plus 3x2 greater than or equal to 2, x1 plus x2 greater than or equal to 1. So next you see, next one what we write, this one will be, we write next page will be, first you write it into the matrix form. So matrix form will be 2 comma 2 3 1 1. Okay, so here minus minus written, so this one will be plus. For this reason I cut this one, so this should be plus 2 3 2 3 1 1, and x1 comma x2, then 2 comma 1, greater than symbol 2 comma greater than symbol 2 comma 1. Okay, so then what will be its dual? Then its dual will be max z, or you can write w or z. Okay, so max zd, max zd equal to what we write? Anybody? Here there may be some wrong, for this reason I have cut and write directly this one. What will be the max zd?
Sir, 2 comma 1 into w1 comma w2,
Yes.
then it will be equal to twice w1 plus w2.
Hmm. Twice w1 w2. Acha, in matrix format what we write? Just you interchange, na?
Yes, sir.
Just you interchange. So 2 3, first column will be 2 3 and second column will be what? 1 1. Clear? Second column will be 1 1. Same as earlier. Second column will be 1 1. So then this one will be, finally what we get? Finally what we get? Anybody? what will be the dual, its dual, just to solve. Final answer will be what will be its dual?
Sir, 2W1 plus W2 less than or equal to 3 and
Yes, good.
uh, 3W1 plus W2 less than or equal to 1.
One. Yes, good. So constraint will be 2W1 plus W2 less than or equal to 3, and objective function will be what, Roshni? Objective function makes ZD equal to
Twice W1 plus W2.
W2. Yes, and W1 comma W2 greater than or equal to 0. Arbaz, clear? Ishita,
Yes, sir. It is.
Yes, sir.
clear, na?
Yes, sir.
Yes. So same as earlier, just I have given here minus minus, and for this reason I cut this one. So you will apply same as earlier method. Okay. Here first you write in the given problem in the matrix form. Okay, matrix form, and then you write its dual. When we write its dual, then objective function will be maximization. Objective function will be maximization. So max ZD. So max ZD equal to, here you see, interchange the role of the coefficient of constant term and means objective function and constant terms. Okay, constant terms and the coefficient of the objective function. So here you see I have interchanged 2 1. So in place of 3 1 we can write 2 1. Okay, and in right hand side constant part you can write 3 1. So when we write this one, then maximum ZT will be twice W1 plus W2, then constant will be twice W1 plus W2 less than or equal to 3, and 3W1 plus W2 less than or equal to 1, W1 comma W2 greater than or equal to 0. And next you see next you see I have given two questions. Okay, you will try to solve, means find write the dual of the following problem. So one problem I have given max z equal to x1 plus twice x2 such that twice x1 minus 3x2 less than or equal to 3, 4x1 plus x2 less than or equal to minus 4 x1 comma x2 greater than or equal to 0. And another problem I have given min z equal to 4x1 plus 6x2 plus 18x3 such that x1 plus 3x3 greater than or equal to 3, x2 plus twice x3 greater than or equal to 5, and x1 comma x2 comma x3 greater than or equal to 0. So here you see, here x2 and x3 where absent, then you write 0 into x2 or 0 into x1 like this, and then you make the coefficient matrix. Then when we write the dual, then you write the transpose of the coefficient matrix, and first you check whether this is the standard primal form or not, then you solve this problem. So clear how to write the convert primal problem to dual problem?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, actually this part is not tough. Okay, Total, this paper is very easy, means what? Just length calculation is lengthy. Otherwise, this is coding subject. Because you see in second sem you got second semester discrete maths. Okay, these are theory based. Means all, if you know all the theorem, then you can solve the problem. Okay, and here just if you know the technique, one problem if you solve very carefully, then remaining problem you can solve. Just if you know the problem, means problem of theory, means calculation part is important one. Okay, so okay, so next one will be, you see, next one will be the dual of a mixed system. The dual of a mixed system means what? Here sometime what happen, in your constraint has a sign equal to symbol. Okay, sometime this is happen in your question. Inequality means in your constraint, first one is greater than or equal to symbol, second constraint is less than or equal to symbol, third one is suppose equal to symbol. Okay, so here how to solve, means how to solve this problem, right, is dual. Okay, so first you check your objective function is what, maximization or minimization. So if maximization, then all your constraints should be less than or equal to. Suppose first constraint is greater than or equal to symbol, then you make it into the less than by multiplying both sides by -1. Second constraint is less than, so no problem, this remains same. Constant is suppose equality symbol. So from equality, how to convert it into the greater than symbol and less than symbol? What is the rule? From equal to, how to write greater than and less than? Arbaj, Roshni, if equal to symbol is present, say x equal to 2. So how can we write? This is less than, and the inequality symbol, how to write? Anybody? Ripon? Vakyasri? I am audible, na?
Yes,
Yes,
sir.
sir.
So, suppose x equal to 2. So, how to write it into less than and greater than? You see, equal to, from equal to symbol, suppose one equation say x less than or equal to 2. And another equation is x greater than or equal to 2. Combining this, we get equal to symbol. Same as subset, means A is subset of B. B is subset of A. Then we can write what? A equal to B with this concept. So here you see the dual of a mixed system. So portion is what? It is a system consists of mixture of equations, inequalities in either direction. Okay, either means either less than, both are less than or greater than, like this. Non-negative variables or unrestricted variables. Then the dual of the problem can be obtained by reducing to the form. For this, the following problem is adopted. So unrestricted in sign, next class I shall discuss. If a constraint has a sign greater than or equal to O, then multiplying both sides by -1 and make the sign less than or equal to. If a constraint has a sign equal to, that is an equation, then it is replaced by two constraints involving the inequalities going in opposite direction. Opposite direction means one will be greater than or equal to, another one is less than or equal to. So you see I have written these two. summation aij xj, j varies from 1 to n is less than or equal to aij xj, j varies from 1 to n greater than or equal to. Then suppose we need all should be less than or equal to, then second one we convert multiplying both side by -1, then minus summation aij xj less than or equal to minus bi. Okay, and number 3 point is important one. Every unrestricted variable is replaced by the difference of two positive variables. Okay, so unrestricted variables, next class I shall discuss how to, if unrestricted variable is present, when present, then seeing the equation we can say how many unrestricted variable will be present in the problem after the solution. Okay, so just you will see the theory and you will solve this two question I have given, you will try to solve. Clear this one, today's topic?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so response your name.